Sorry I couldn't be there today, guys, but I did want to give you a little intro to our parallel line proofs, which is the next topic we're going to be looking into. So just make sure that you finished your IXL benchmark assessment before you start this video. So if you haven't done that yet, pause it, go back and finish, and then come back to this. All right? But the main thing we're going to take a look at today is a couple of real short proofs just to get the idea of how we're going to, first of all, do a proof statement or do a statement where we want to say the lines are parallel and what reason we're going to give. And then we want to talk about what happens if they give me the lines are parallel. What can I do with that information? What do I do with that to get more things equal or more angles equal? So we're going to take a look at that as well. Okay. So let's start back up here at number 1. So if you remember in your statements of reasons, first one we're going to do is write the givens. Okay, so we already know that angle 1, which is this angle up here, is congruent to angle 4, the one down here. Now remember, these two angles, these are vocab words, are alternate exterior angles. And if those are congruent, right, then we know that we have parallel lines. So just to recap here, we talked about back in lesson 7 here, day 7, about our types of angles formed by two parallel lines cut by a transversal. So when we know the lines are parallel, okay, we know, and there's a transversal cutting through them, we know that these type of angles are going to be congruent. So if we think about that kind of backwards, right, if we have either same side exterior, same side interior angles that are supplementary, or we have a set of alternate exterior, alternate interior, or corresponding angles that are congruent, any one of these 5 things is enough to make those lines, to say those lines have to be parallel. So if I have a z here with these 2 angles equal, I know the lines are parallel then. And that's something I could use to prove parallel lines. Get one of these 5 things to happen, and then that's enough to say that the lines are parallel. Okay, so if we go back to our proof, because these are alternate exterior angles, and we know they're equal from the given, now I can say for step number 2, the proof statement, that line L is parallel to line M. Okay? Now the reason for that, period, is going to be what type of angles are we? Are they already? And because of that, the lines are parallel. So we're going to say when alternate exterior angles are congruent, let me just say the lines cut by a transversal are parallel. Okay? Now, anytime we're proving those parallel lines, we're just going to take this part and swap it for whatever angle pair we have, and the rest of it is going to stay the same. Okay, so we'll see that in the next one. So number 2, now this scenario doesn't happen a lot, but we'll just take a look at one that could possibly happen. We have angle 1, and we have this angle 3. Now they're not equal, so different arcs, but we do know that they are supplementary. They add to 180. So once we know that, and these are same side exterior angles, that's enough to prove the lines are parallel. You'll normally see corresponding alternate interior or alternate exterior angles. So this is just, I'm just doing kind of a just in case type thing. So once we know that this is true, right, we have our same side exterior, we know they're supplementary, that's enough now to say for step 2 that L is parallel to M. So for reason 2, remember we just wrote down when same side exterior angles are supplementary, then we can say the lines cut by a transversal are parallel. It's the same thing we wrote here, we just swapped out what type of angle pair we have. Okay, This reason's kind of annoying. I know it's a little bit longer than the other ones, but it's something we got to get used to kind of saying. All right, for number 3, we're swapping it up here, so we'll switch colors. We are going to be trying to prove that our angle pairs are either equal or supplementary, but we know, and this is something we can kind of put down for ourselves, that these two lines are parallel. We can kind of put those arrowheads on. So if the lines are parallel, remember that forces these two angles on the same side exterior to be supplementary, or we might do like alternate exterior angles or congruent, one of those things. So remember, this is what we're trying to prove. We have enough information in the given to do it. So for step 2, we're going to write angle 1 and angle 2 are supplementary. You could also say that they just add to 180 in case that was something you were trying to show. Okay, and this time we're going to do a little bit different. Now, if you notice in the first one, we said the angle pair first, and then the lines being parallel second. When we are trying to use the parallel lines, we have to put that first and say when the two parallel lines cut by transversal, then the angles are congruent. So we're basically going to swap these two positions here, okay? So this is what it's going to look like. We're going to say when two parallel lines are cut by a transversal, and then we're going to now describe the scenario we have, comma, right? Same side exterior, and we're always going to use our vocab there. That's why it was important to know that. Angles are supplementary, or we can say add to 180. It's also fine, and that's it. So notice, right, that this part right here is always going to stay the same, okay? And then we are just going to swap out that part. So notice that the angle part came second and the parallel line part came first, okay? All right, see if you can try this one on your own. See if you can try number 4 on your own. So pause it here. Look at the angles 2 and 3. See what the relationship is, and then see if you can come up with the reason on your own. Okay, try it first. All right. Hopefully, you notice that these two angles are alternate, right? Exterior. So because the lines are parallel, that's enough information to get those angles congruent. So we can say angle 2 is congruent to angle 3. Remember, we're going to write down the same start as last time. When two parallel lines are cut by a transversal, put a comma, and then add our angle information. Alternate exterior angles are congruent. Okay? And that's enough. All right. Now that we have some kind of idea of how we're going to write up that statement of reason for these parallel line proofs, let's check out some proofs and let's see if we can do some proofs involving parallel lines. So a little bit more in depth here. All right, a little bit easier one to start with, and then we'll build our way up. So let's take a look at the given. First thing I was going to do, so if you haven't already, statements and reasons. Go ahead and pause it and do that. And I noticed that I made a mistake. This is supposed to be a 1, not a 4. All right, and let's go mark it. So we know that angle 1 is congruent to angle 2. So let's say, for instance, that we knew that both of these were 50 degrees. Okay, we also know that angle 3 is congruent to angle 1. So if these two are equal, that means that these two angles have to be 50 degrees, and that makes all 3 equal. Okay, now, super important, we are trying to show that line BC, which is this line right here, is parallel to line EF, okay? Angle 3 and angle 1 are not on the same transversal here, right? So if you noticed, this line would make our Z. So this angle we could get right here to be 50, but that involves these two lines. That involves these two lines, making the top and bottom of our Z. So we can't even do that. But instead, what we would want to notice is, if we're trying to show that these two lines are parallel, this is my transversal here, okay? I would have to use these angles right here to get those lines parallel, okay? One is not involved in this intersection here. So you can kind of get the idea that if I extended this line out here and this line this way, now we have our two parallel lines cut by a transversal we kind of talked about up here. So look at angles 2 and 3, right? What's the vocab word that ties these angles together? Hopefully you just saw that they're corresponding angles. Good. So if we could get these two angles congruent, that would make them because they're corresponding, that would force these lines to be parallel, and that's the idea here. Okay? Now, if you notice, we have 1 congruent to 2. These two angles are equal. Remember we said before, if these are both 50, right, and 1 and 3 are congruent, then we have to know that these two are congruent. And that is called the transitive property. Or we could talk about substitution, right? If I take 1 out, I can put 2 in its place, right? That type of thing. So we're going to say for ourselves right underneath that angle 2 is equal or congruent to angle 3. And then over here, okay, we're going to add our transitive property. And you could describe this also as substitution. Okay, now, a quick note. Because we don't have an M in front of these angles, we should be using the congruent symbol here. So we're going to go back and just add that on, okay? If we're using equals, then we should use the M, congruent, no M, okay? So for number 3 now, remember, since we know that these are our corresponding angles, now we can say that these two lines are parallel to one another.
We can say that these two lines are parallel to each other.
We got a special guest, Kate Sazowski, in the house.
I am the best person ever.
All right. Thanks, Kate. Now we're going to finish off our proof by describing our information. Now remember, we don't have the lines are parallel, so we're going to go back up here to when we proved them. We're going to say when the angles, then the lines, okay? So we're going to say when, let's use our vocab words, when corresponding angles are congruent, and then the lines, we can say cut by a transversal are parallel. And that's it. We're done with that one. Okay? All right, let's hop down to number 6 when you're done. And let's take a look at this proof. So, once again, if you haven't already, make sure you fill in the givens for your first statement, and given is your first reason. Okay, now some pro tips here. A couple things we want to keep in mind. Anytime it tells us anything's congruent in the given, like 1 and 4, we want to immediately go over to a diagram. We want to use those arcs and mark those two angles up so we know that they're equal. All right. Now, second thing, we're going to look for any ways that we can build new statements. So in your givens, are there any key vocab words like bisects, right? And if there are, and we know what that means, okay, then we're going to go mark that up, okay? And we're going to create a new statement and reason from that. So if QT bisects angle PQS, now angle PQS is this angle right here. So if I bisect it, remember it means cut in half, then I'm going to cut that line in half using QT. So angle 1 here is going to be congruent to angle 2. So right underneath, right, if we bisect the angle, we get these two congruent angles. So we're going to write angle 1 is congruent to angle 2. All right. And remember that the word is bisects. So that's going to be definition of. And what are we bisecting? We're bisecting an angle. So definition of angle bisector. Okay? And that's it. That's how we write up that statement. So now that we know that that's true, we can kind of mark that up in our diagram, right? We can mark angle 1 congruent to angle 2. Now, if you get stuck I've used my statements and reasons. I've marked up my diagram. I don't know where to go from here. Let's go look at the proof statement and let's see if we can kind of work backwards here. So if I want to show that QT is parallel to RS, okay, well, QT, right, is this line right here, and RS is this line right here. So in order for these two lines to be parallel, I have to have one of those angles pairs we talked about. I have to have corresponding, alternate interior, alternate exterior, same side interior, same side exterior. Remember, one of the things we mentioned before was there are some angle pairs that you can use, right, to make that happen. And one of the things that we can do is look for our favorite letter, right, our favorite letter. And there is a Z being drawn right here. So if I can show that angle 2 right here is congruent to angle 4, and they form a Z, that means that these are alternate interior angles and that forces our lines to be parallel. So in order to get these two lines to be parallel, right, I need to show, we'll say NTS, need to show that angle 2 is congruent to angle 4. That's what I have to happen first, and then I can do this. Okay, now let's go look. We said in step 1 that 1 and 4 are equal, and step 2 is 1 and 2 equal. Do you see how we can get these two equal together? All right, hopefully you're thinking the same property I am, right? Which is the transitive property. And because these two angles are both equal to angle 1, now we can say that angle 2 is congruent to angle 4. And remember, we just talked about, because those angles form a Z, now that's enough to say that QT, that line segment, or that line, is parallel to RS. Technically, these should have arrowheads on the end of them, if they're lines. And remember our statement for this. Okay, now we're proving the lines are parallel, so we're going to start with when, what's happening? The alternate interior angles are congruent. Okay, the lines cut by a transversal are parallel. And that's it, we're done. Our proof statement is our last statement, so we're good to go. All right, I'm just going to fix this. Awesome. Okay, last one, a little bit more involved here. Okay, so we have two main givens. We know, first of all, that angle ABD, which is this angle right here, okay, is congruent. So this whole angle right here, that whole thing, is congruent to angle FDB. So that's this angle down here. These two angles right here are congruent. All right, I also know that this angle 1 is congruent to this angle down here 4. My job is to show that this line, RC, is parallel to EG. So, we've marked our congruence. We don't have any keywords. Maybe we're stuck. So let's start with our proof statement and work backwards. If these lines were parallel, right? If these lines are parallel, what angle pairs should be equal? And hopefully you see it. Hopefully you see it. There's a Z again going on this way, right? So if I can show that angle 2 is equal to angle 3, okay, that'll be enough to get the lines parallel. So that's my goal, all right? So in order to show these are parallel, we need to show that angle 2 is congruent to angle 3. All right, let's see if we can do it. Now, in class, if you look behind you on the wall, right, across from the door, there's a poster over there that says that the angle addition postulate is what it says. We're going to call it the angle addition property, okay? So we're going to call this the angle addition property. And what it says is this. If I have two adjacent angles, okay, and I add them together, they're going to equal this whole angle. So I know that angle 1 plus angle 2 makes angle ABD. So where it says ABD right here, okay, I'm going to replace that with this sum, angle 1 plus angle 2. All right? And on the same time, where it says angle FDB here, we are going to replace that with the angle pair for FDB, which is 3 plus 4. So we're going to say equals angle 3 plus angle 4. And you're saying, why do we do that, right? Remember what we know from the other given, right? We already know that angle 1, and angle 4 are equal. So if we're trying to show that 1 and 2 and 3 are equal, and we have an equation here, remember behind the scenes we can subtract angle 1 or angle 4 from both sides, and because they're equal, they will drop out of our equation. That's what we're trying to do here, okay? Now remember, we don't actually show the work. All right, so we just say if I subtracted these two angles, I'll get angle 2 equals angle 3. And the reason for that, when we do that subtraction, remember, is called the subtraction property of equality. So this is a concept we were working on the last time we did proofs, right? Which was when you get two things equal to the same amount, you set them equal to each other, and then you subtract away the part that's equal. Sometimes the thing that's equal isn't the same amount, but it's something that's equal to each other. All right, and now that we have 2 and 3 equal, which is what we wanted to show, now we can say that our lines RC and EG are parallel. And remember how I'm going to write that up now. So we're going to start with when, and what do we have? When the alternate interior angles are congruent, the lines cut by a transversal are parallel. And that's it, guys. We're done. Thanks for joining me. Hopefully this gets you an idea of how we're going to do these. And we'll spend the next few days working on these proofs before we do any tests or quizzes. So we'll make sure we have a good solid foundation. All right. And I'll see you guys tomorrow.